Problem number 4. While walking along a dock, Amanda accidentally kicks an anchor into the water, but manages to grab the rope before it falls into the water. She notices that when the rope is pulled taut directly above the anchor, there is 1 foot of rope above the water. If the rope is pulled taut but to the side, the end of the rope touches a point on the water surface 7 feet away from the point on the water surface directly above the anchor. How deep is the water? Alright, well, let's draw a picture of what's going on here. We don't know how long this rope is, but let's just draw a picture here. So we have a water line here. I'm just going to draw this water line. And the anchor falls into the water and is attached by a rope. So here's the rope. Pretend this is straight. And you get an anchor down here. And okay, so Amanda's up here on the dock. And let's say this is the end of the rope. And it's 1 foot. The end of the rope is 1 foot above the water when she pulls on the rope directly above where the anchor fell in. Okay, so let's say that the depth of the water is x. All right, so the length of the rope then is equal to the depth of the water plus 1 more foot. Okay, so that is what we're given. And then also they tell us that if she pulls this rope over to the side 7 feet, then so if she pulls it over, then the rope just touches the surface of the water over here. Okay, so the rope is still, let's see, I shouldn't say, the rope is still the same length, right? So the rope is x plus 1 foot, right? And the water is still the same depth, right? So that's x feet deep. The rope is x plus 1 foot long. And so you can start to see a triangle here, can't you? And when the rope is directly above the anchor, it's going to make a 90-degree angle with the surface of the water. So you see we have a right triangle too. So now we can just apply the Pythagorean theorem. So the Pythagorean theorem, what does that tell us? If we're given a right triangle where the legs are length a and b and the hypotenuse is c, then a squared plus b squared equals c squared. So the legs in this case are, well, let's see. We know that this is 7 feet because she pulled, this distance here along the water. Let me highlight that with a different color. So this distance here along the water is 7 feet because she pulled the rope over to the side 7 feet and it just touched the end of the rope touched the water over here. So we're given, well, actually we're we're given this length, this leg, okay? We know that the depth of the water is x, which is not really, that's what we're trying to find, right? And we know that the length of the rope has to be the depth of the water plus 1 more foot. So let's just plug in what we know. So let's call the two legs are x and 7. So x squared plus 7 squared is equal to what? It's equal to x plus 1 squared. Okay, x plus 1 more foot squared, because that's the hypotenuse. It's the angle that's directly opposite the right angle. Alright, well, let's just expand that out. So we have x squared plus 49 is equal to, now, there's a number of ways you can get the square here. I don't know how familiar you are with this, but you could write it out as, x plus 1 times x plus 1, and then use the distributive property. That's one way to do it. So you would take the x plus 1, this whole thing, times x, alright? So you have x plus 1 times x plus 1 times x plus 1. And then you'd have to distribute this, alright, down here. So you end up with x squared plus x plus x plus 1, which is equal to x squared plus 2x plus 1. Okay, now after a while you'll recognize that if you have like x plus a squared, once you do these things for a while, this one has a nice form, you know, just x squared plus 2ax plus a squared. Okay, you know, you use it enough and that you're just going to remember that. But if you don't remember that, you can always work it out by using the distributive property. Okay? Alright, so we have, let me copy this down here, we have x squared plus 49 is equal to x squared plus 2x plus 1. Well, I can subtract x squared from both sides, right? And then x squared minus x squared is 0, and x squared minus x squared is 0. So we get rid of the x squared. So we're left with 49 is equal to 2x plus 1. And if we subtract 1 from both sides, 48 equals 2x. So x is 24. Alright? And that's what we're looking for. We defined x. I probably could have done that. So x is the depth of the water, which is exactly what we want to know. How deep is the water? And our units are in feet, because this one here, we were told that it was 1 foot above the water when it was pulled taut, directly above the anchor. So everything's in feet. So this is 24 feet, and that's our answer. So the water has to be 24 feet deep if you have a rope that's 1 foot above the water line when it's pulled directly above the anchor, and is right at the water line when it's pulled 7 feet to the side. Okay? So there you go. The answer is 24 feet.